Okay, now we're recording. So this is problem 8 from section 8.3 that we're going to be working on. So it's the company's revenue from selling X items is given by the function R of X, and the cost is given by C of X. All right, so let's see what we can do with this thing. All right, so first of all, they want us to write a function P of X, which represents the company's profit from selling X items. So we need to remember from our previous work about how the relationship between cost, revenue, and profit goes. So we know that P of X is equal to R of X minus C of X. So that's how you generate the profit function, P of X. So to do that, we got to come back up here and we got to grab our revenue function and we got to grab our cost function. So let's do that, and we're going to get that P of X is equal to 680x minus our C of X, which is 10,000, plus 2x squared. Notice the use of parentheses, muy importante. If you forget those parentheses, you're not going to get the right function for P of X, because you need to remember that what that negative out front right here is really doing, that's a -1. We're going to distribute that -1 to clear the parentheses here. And so when we do that, our newfound friend P of X is going to be equal to 680x minus 10,000 minus 2x squared. Okay, so it would probably behoove us and be worth our time to go ahead and put that thing into standard form. So let's do that also real quick. So one last time, writing down P of X, putting it in descending order, it is minus 2x squared plus 680x minus 10,000. Okay, so identify the vertical intercept of P of X, write it as an ordered pair, and interpret the meaning of this in a complete sentence. Okay, so you got to remember what this function is. P of X gives us the profit based upon how many of these things that we have made. So in order for us to find the vertical intercept, that's the y-intercept. And when we're talking about the y-intercept, what that means to us is that x was equal to 0. So when you're asking for the vertical intercept, what they're asking you is, what is P of 0? Let's not make any product whatsoever. And you get minus 2 times 0 squared plus 680 times 0 minus 10,000, which says you are in the hole $10,000. So you've lost $10,000. I'll let you write the sentence that goes with it, but that's what it means. It means you've lost $10,000. So the ordered pair is 0 by minus 10,000. There was a question very similar to this one on the midterm. Was the one where you guys had to write out the actual answer and tell me what the functions meant? Okay, so how many items must be sold in order to maximize the profit? Okay, so let's stop for just a second and talk about this particular function up here. So if we look at P of X, we see that the leading coefficient here, the A is less than 0. And when A is less than 0 on a parabola, we know that that's its shape. It's going to be concave down or it's going to open downward. So this is a downward opening parabola. And so what that tells us is that the maximum profit, if this is our profit function, is going to occur right here at that top point. And we know that that ordered pair at that top point right there is given by HK. That's the vertex of our parabola, right? So to figure out what those values are, we got to remember the little formulas that they gave us. They gave us H was equal to minus B over 2A, and K was equal to F of H. In other words, whatever you got from the first one, you plug that into the function, and that gets you the second answer, okay? So how many items must be sold in order to maximize the profit? Well, we only need to know what H is right now. They don't, in this question, they're not asking us for the maximum profit yet. They're just asking us how many need to be sold for the maximum profit. So to get that, let's come back up here for a minute. We've identified A to be equal to -2, B is equal to 680, and C is equal to -10,000. All right, so let's go figure out what h is going to be equal to. H is equal to the opposite of b, so that's negative 680 divided by 2 times negative 2, because a was a negative 2. And so that's going to give us negative 680 divided by negative 4. So move you guys around a little more here. So negative 680 divided by negative 4, and we end up with 170. So it looks like the number of items to be sold to maximize the profit is 170. So sell 170 to max profit. Charlotte, let me know if I'm going too fast or I'm not being thorough enough. Don't be shy about stopping me.
It makes sense now. I missed one step, and when you miss a step, it's wrong.
Math's kind of weird that way, isn't it? You miss one little piece, the whole damn thing falls apart, doesn't it?
Yep.
Crazy. All right, let's go ahead and finish this bad boy up. Okay, so what is the maximum profit? Okay, so with the maximum profit, to figure that out, we got to go find out P of 170. So P of 170 is going to be negative 2 times 170 squared plus 680 times 170 minus 10,000. So that's going to be our maximum profit. So let's go just check that real quick, make sure I remember that function correctly. Yep, I did. Okay, cool. So we're going to go to the calculator to do that. So let me shrink the screen so I can see what I wrote here. So that's going to be negative 2 parentheses times 170 squared plus 680 times 170 minus 10,000. So maximum profit is $47,800. I wouldn't put much money into this company if I was you guys.
Oh.
So 47,800. Must be a Trump subsidiary. So how many items does this company need to sell in order to break even? Okay, so remember what break even means. Break even means that the profit is equal to 0. It means that you didn't lose money, but you didn't make any money. So your profit comes out to be exactly equal to 0. So that means we need to solve that 0 is equal to negative 2 x squared plus 680 x minus 10,000. Okay, now we have some choices here how we want to solve this. We can use the quadratic formula, or we can try and do it by factoring. But either way, I strongly suggest that solving a quadratic like this, we do two things. First one is we make the leading coefficient positive, and the second thing is we get rid of any common factors that happen to be in there. So in this case, the greatest common factor on the right-hand side there is equal to negative 2. In other words, everybody's got a factor of 2 in them, and I'm going to take out a negative 2 just to make it easier. So if I do that, then that's 0 is equal to negative 2 times parentheses x squared minus 340x. Notice negative 2 times negative 340 gives me a positive 680, right? Plus 5,000. And that's going to be a much simpler quadratic to solve, either by factoring or the quadratic formula. It doesn't matter which one, if I get that common factor out of there. And notice this common factor, I can ignore it now because it is not making the right-hand side equal to 0. Negative 2 doesn't make everything equal to 0. It's whatever the x values are. So when I go to actually solve this, I can just ignore that negative 2 completely. So I'm going to punt and use the quadratic formula because I'm not seeing the factors off the top of my head here. So x is equal to the opposite of b, which is going to be the opposite of 340 negative, plus or minus the square root of b squared, which is 340 squared, Take the negative there if you wanted. Minus 4 times A, which is 1, times C, which is 5,000. All of that divided by 2A, which is going to be 2 times 1. Okay, so let's go get the calculator back out here to help us with this, because I'm going to try and do this by hand, obviously. So let's see here. So clear this thing out. So we're going to go parentheses to open the numerator, 340 plus square root of parentheses 340 squared. By the way, if you haven't got the quadratic formula memorized yet, you need to get after that, because that's really important, okay? Minus 4 times, and I don't need to put the 1 in there, so I'm just going to put the 5,000. Now, if you got an old dog 83 or you're using an iPhone, the square root did not expand across what you're putting there. You have to open it with the parenthesis and close it with the parenthesis. If you don't, you're not going to get the right answer. And similarly, if you're one of these new fancy ones, to get out of that square root, you got to hit the right arrow to get away from it, to close off the parentheses, to close off the numerator, and divide that whole thing by 2. Okay, so I do that, and I get back 324.5962. So Charlotte, is that what you got?
That was what I got.
Okay, cool. That's always good. I like it when we get the same answer I do. All right, now you can, if you want to, get the second answer by just going second enter. It'll replay the last thing that you did and scroll over to where the plus was and change that to a minus. But when we do that, we get a crazy number, right? We have 2 break-even points. We have 2 places where we make 0 profit. One of them is if we make 15, basically 16 of the products, and another one is we make 325 of the products, basically. So we're not break-even. Yeah, those are the break-even points. Excuse me. Yes, those are the 2 break-even points. So there are 2 break-even points here. So that happens sometimes. You get some the weirdness in the model. So the break-even points are going to be at x equal to 325 approximately. I'm going to round off to the whole item because we're not going to do partial product, right? And the other one looks like at about 15. Gina, is any of this making sense?
Oh yeah. Yeah, it is. It's starting to
gel.
Mm.
Okay, well, I'm recording this one too, so after you give it a shot, you can come back and watch the video, okay?
I will.
Okay, so in terms, I'll let you write up something about it if you want to help it make sense. But those are the values that where the company is going to break even in a probably a really good idea, although they didn't ask us to do this, is to think about this thing from a graphical standpoint. And that what we've got here are 2 intercepts, one of them at 15 and the other one at 325, and then the other intercept is down here at negative 10,000. This one here is at roughly 15 on the x-axis, okay? And this one here is roughly at 325.
Okay.
So if we were to put these in ordered pairs, this one's at 0, negative 10,000. This one's at 15, 0. And this is at 325, 0. And then this point up here, that's the maximum profit that we found a minute ago. That's the 170 by 4,700, or 47,800, excuse me. So seeing all those numbers in the graph sometimes helps see kind of what's going on, right? That you had 2 places where you pierce the x-axis. Down here, what this all of a sudden now becomes a negative profit again. You're losing money. You saturated the market. Nobody wants to buy your stuff anymore. And then, over here is you just sold enough of them to make it work. So, and these numbers may be in, united. Maybe they're in thousands or 10,000s or something. Okay, practical domain and practical range. Okay, so let's talk about what the practical domain and the range is. So in terms of reality, that's usually what we're talking about. We're talking about practical domain and range. Is that X is going to go between 0 and 325. The company is not going to make more product than they're going to make any money on. So that's the reality. In fact, if they're good, they're smart people. So you could put an argument in here that this number should really actually be 170. Because, you know, after they maximize their profit, they're not going to make any more than that. And then the range, which is the actual domain over here. The domain is the number of products. The range is your P of X. That's your profit, okay? And the P of X on that, it's going to go from where? Well, negative $10,000, because if you start up, you lost $10,000, is going to be less than or equal to P of X, which is going to be less than or equal to $47,800. Because that's the maximum, that's the biggest that the profit can be. Those practical domain and range questions are difficult. They're not necessarily unique. In other words, solutions don't have to be unique, but they have to make sense. You can't, like I'll see people who say, oh, well, the domain here, the domain, that's all reals. So you can make a negative number of product. And you can make an infinite number of product, you know, so things like that just don't make sense. So, you know, there's lots of room for wiggle on what a correct answer would be here, but there's definitely kind of a set amount of things that are possible. Okay, so that's getting a little long-winded. We got any other ones that we want to work on?
That's all I had.
Okay.
I think I'm okay.
You sure, Charlotte? Gina, you sure? Come on. You want to do one more of them logarithm of thingies?
Okay.
Yeah?
Sure.
Pick one of them logarithm things that are torturing your life.
You know what? Desmos is torturing me right now. But
Really?
I'm just going to go back and watch your videos again and read through it again.
Okay.
I'm still stuck on the Desmos, but I'm just going to read over it again and watch through it again. And
so which one? The Desmos on the parabolas, on the marble slide on the parabolas? Is that the one that's?
Yes. The ones that you just did. The ones that you did a video for. I'm sorry, I'm tired.
That's okay, Gina, it's all right.
That's my bedtime.
Yeah, sure. Don't make me think math this late. All right, let's see, which Desmos? It must be marble slide quadratic, the new one.
Mm-hmm.
Yeah.
I hate the marble slides.
No, you love the marble slides.
The marble slides are fun.
The marble slides are my friends.
Then I don't think I get them.
You know, don't be shy, whatever group you're in, saying, look, can you guys, you know, tell me what you did, you know? Or if you need me to do more video, I'd be happy to do that. So how about the question on that? That's the thing is do you know what H and K do to a parabola?
I'm learning, but I still don't understand how to make up a question. I mean, I'm not getting.
Okay, let's do one. Let's do one. You can't use this one, but we'll
okay.
do it, okay?
Okay.
But you've got promised me you don't use these numbers, all right? All right, okay. You gotta make up
I won't do that.
Okay, here we go. All right, so let's do part number 5. It says give a function of the form looks like this, and ask your reviewers to explain what A, H, and K do to the graph. All right, so let's do that. So here's how you do it. This is actually, excuse me, this is a golden way of doing it. So you come in and go, okay, I'm going to go y equals -2 times x plus 3 quantity squared minus 4. Whereas I'm just grabbing numbers, boom, pulled them out of my ass, all right? I just threw them numbers in there. You with me? Okay, cool. Now, I got to know what do those numbers do to my parabola.
Okay.
Right? Now, I know a couple of things. Some things you're going to have to bring to the game. One is that if A is less than 0, I know it opens like that, okay? It's a downward opening parabola. If A is greater than 0, I know it is an upward opening parabola. So those two I got to know right away, all right? So what I know about my parabola, since my A is negative, right?
Mm-hmm.
See, that one there is A. That one there has something to do with H. We'll talk about that in a minute. And that one there has to do with K, right?
Okay.
All right. So I know already that I got a downward opening parabola because I picked a negative number for A. All right, cool. All right, now what else do I know? Well, I know that the standard form is y is equal to a times x minus h quantity squared plus k. And if I don't remember that, I'll look it up, all right? So I got to figure out what the ordered pair for hk is. Well, k is easy. K is just whatever the number is, so it's -4. It's h that's kind of a pain in the butt. You always have to change the sign on h. See, it says the opposite of h, so you take the opposite of it, right?
Mm-hmm.
So that means it's got to be a -3.
Okay.
Okay?
Okay.
All right, so now what I know is I know that this point right here, the vertex point, I know that's at -3, -4. All right, so now here's the part that's golden. So we're going to go into our calculator, and we're going to actually put that thing to my calculator. We're going to take a look at it. So we're going to go into y equals, move it over here. Let's clear out all the craziness I got in there. And let's put in -2 parentheses x plus 3 squared minus 4. Don't know any better, so let's do a zoom and a 6. Oh, there's my parabola. Right? Okay, so here, let's go back to the question now. Let's see if we're going to make this question work for me. It says, give a function of the form y equals a times x minus h squared plus k, and ask your reviewer to explain what the values of a, h, and k do to the graph. All right, so you have to be able to answer that question, whether they got it right or wrong, right? So, make this bigger for you so you can see it. So what I know what it did to my graph is it moved it. It changed its shape and it moved it. And the way you can see that is that we're talking about, when we say what did it do to the graph, we're saying what did it do to x squared, which is the stock graph. So there's the stock graph right there, right? So what did those values do? Well, first it flipped it over, made it skinnier, right? And then it shifted it over 3 units to the left and down 4. So this point right here, that point right there, we know is at -3, -4. So coming back to answering the question here. So say you're answering somebody else's. Okay, let's just, because you got to answer your own, because you got to make sure people are answering, right?
Mm-hmm.
So you would say A flips it over the x-axis, right? H shifts it, and then you look at this number right here, -3 units to the left, right? Or you can just say 3 units to the left. That probably would make sense too. And then what does K do? K shifts it 4 units down.
I get it.
All right, well, I'm gonna make you show me that, all right?
No.
Yeah, I mean, okay?
Right now?
Give me an A.
Oh, right now?
Yeah, just give me an A, any A.
Oh.
Give me a number. 3, okay. Give me an H.
5.
Okay, give me a K.
7.
1, good choice. Want to keep it on the screen, do you know?
Okay. 72.
Make those numbers small, okay?
Okay.
All right, so we got y is equal to 3 times x plus 5 quantity squared plus 1. Right?
Mm-hmm.
Okay, well, what do we know? A is greater than 0, so what does that tell me? Is it open up or open down? Cool. All right, what's h equal to?
H is equal to 5.
Yeah, it is. And I kind of made a boo-boo. Sorry, timeout. This part was kind of hard. If h is equal to 5, right? You got to put it into the equation correctly, and I didn't put it in the equation correctly. So bad on the teacher for going fast and being flippant. So what do I mean by that? Well, what was the equation? It's always a good idea to write it down underneath it, then you won't make this silly mistake that I just made. What's the sign between X and H? Yeah, and I put a plus on there. Oh, bad on me. There we go. So H is equal to 5. You're correct. So what does that do to the parabola? Which way does it move it?
Right.
Yeah, it's going to move to the right. Okay. So that's going to go to the right 5 units. And then what's K equal to? K is equal to 1. So what's that going to do?
Moves it down. Up.
It goes up.
Yes.
It goes up. Okay. And so you can check that by going into the calculator, seeing whether you guessed that right or not by typing it in. So we're going to go 3x minus 5 squared plus 1. Okay, so what did it do? Well, it's still upward opening. Since it's 3, it's going to be skinnier. Okay, if it's bigger than 1, it's skinnier. If it's between 0 and 1, it's fatter. It flattens it out. Okay, but it shifted it 1, 2, 3, 4, 5 units to the right and 1 unit up. Right, there's the vertex right there. So don't be shy about playing around with it on your calculator first. Okay. In other words, make it on your calculator. Right now, same thing on the question that gets asked of you. Right. So when you come in to ask somebody, the first thing you should do is put that thing in the calculator.
Okay.
And say, oh, well, look at that. It shifted it 5 units to the right and 1 unit up, and it was 3, so it opened up a little bit skinnier.
Okay. I can.
So yeah, don't be shy about using your technology to help you out there. Okay.
Okay. Thank you.
All right, so what if they asked us for the domain and the range in this one? What if we were asked to do that? Let's pretend that this one was our question. We had to do the domain and the range in. So again, I would look at the calculator. First of all, the domain on every quadratic, so all quadratics have exactly the same domain. And the domain on every quadratic is equal to all real numbers. So that's a done deal. That one's easy. It's boilerplate. It's the range that's a bit of a pain in the butt. So the way to get the range is go look at the graph and say, well, look, I start at 1 and I head that away, don't I? Because remember, when you're talking about the range, you're talking about the y values. And so the smallest y value was a 1, and then it just got bigger from there. So the range, that goes from 1 to positive infinity. And sometimes it helps if you turn your head sideways or turn your computer sideways. In other words, take your laptop and turn it this way and go, oh, I see it. I'm going from 1 to positive infinity, right? I'm not kidding. It really helps if you do that, or turn your calculator sideways.
Okay.
All right. So what's the next question here? Let's see. Then on number 7, they say, use the function phi, ask your peer, what is the equation of the axis of symmetry of our function? Okay, so the equation of axis of symmetry is if I went and put in a vertical line that sliced it in half, where would I put that line at? And unfortunately, I just remember you can't get the calculator to do this directly. I have to cheat. Give me just a second here. Since it's not a function, you have to make it a drawing. So, but I can sort of cheat to help you see what it does, what we're looking for here. So what the axis of symmetry is, it's the vertical line that slices the graph right down the middle of it. So the vertical line that takes your graph and cuts it in half. So the left-hand side and the right-hand side are symmetric to each other, that are mirror images of each other. That's the axis of symmetry. And as it turns out, it's actually pretty easy from a mathematical standpoint. All you got to do is take a look at whatever you came for H here So the axis of evil, or the axis of symmetry, we're looking for here, that's just going to be x is equal to h, or in our case, x is equal to 5. So whatever you came up with for your h value and your vertex, that's going to give you your axis of symmetry. All right, one last piece here. Using the function part 5, ask your peers if there are x-intercepts, horizontal intercepts, if they exist, and what is the y-intercept, okay? All right, so if we look at our graph here, let me get rid of the one we don't need. And this is another thing, looking at your calculator really makes this easy. Are there any x-intercepts to this graph?
No.
No, so no, none exist. So whew, that was nice of them. Boy, that gave me a good one here. I don't have to do it. Now, if they did exist, you have to use the quadratic formula to find them. In other words, you got to take the function set it equal to 0, find a, b, and c by multiplying everything out. Or you could use the zero finder on the calculator. I would be cool if you did that too. And you can ask for help on that one in your group. See what they say, all right? Now the y-intercept, that one, again, you just set x equal to 0 and figure out what comes out to be equal to y. So I'm going to let, in our case here, there are no x-intercepts. So what about the y-intercept? Well, for the y-intercept, that means x is equal to 0. So y is equal to 3 times 0 minus 5 quantity squared plus 1, which says that that's equal to 3 times 25, because that's what -5 squared is, plus 1, which gives us back 76 if you multiply that all out. So the ordered pair is 0 by 76. So back looking at our calculator here, way up over here this way, the graph runs into the y-axis at 76 on the y-axis. All right. Did that help at all?
Yes.
Yeah?
Yes.
Yeah?
I mean it.
Okay, I believe you. I believe you. Yeah.
Thank you. I appreciate it.
Okay, and remember, this is recorded, Gina, so, when you go look at it and think about it a bit more, and you go, oh, what the hell did he say? You can come back and look at the thing and, fast forward it, throw things at me, wad up paper and throw it at the screen, whatever helps, okay?
Okay, thank you.
All right, Charlie, you got any more for me?
That's it.
Okay, so why don't go ahead and call that good?
I'm calling it
Yeah.
good.
I'm going to save the recording, and it should be up no later than tomorrow morning, okay?
Thank you.
Okay, you guys have a great evening.
You too.
Regina, don't be shy about posting questions, okay?
Okay.